action.
Hello, my dear students, and welcome to our virtual instruction. This will be for Wednesday, September 30th, end of the month. We're starting a new month in October. I don't know about you, but 2020 cannot get over quick enough for me. Welcome back to my kitchen, where I am going to go over today's activity, which we're going to do a quick lab, entitled Accuracy and Precision. You'll find the assignment either in your stream where it's posted or, of course, under your classwork and coursework section in Google Classroom. And if you will pull up your form, you can be filling it out as we go, except you have a choice. You can do it yourself and use your numbers, or I'm going to show you my numbers and what I got. This is an experiment you can do at home. As you can see, the purpose of this experiment is to practice using significant figures and recognizing them in our measurements, as well as properly handling them in our calculations. And very simply, the materials call for a 3x5 index card and a centimeter ruler, a metric ruler. I have a Ward Scientific Natural Science ruler, and it says use a metric ruler to measure in centimeters the length and width of an index card as accurately and precisely as you can. The hundredths place in your measurement should be estimated, because when you look at this metric ruler, it has millimeter lines. And I can measure this card from one line to another, and if it's a little bit over or a little bit under a line, I can give an estimate for my last place of my significant figure. So, I'm not going to answer any questions yet. I'm going to answer them in a minute. But when I do this, I get the following data. For my index card, when I measure it here in my kitchen with the light that's available, my 3x5, and of course those are inches, which we will never use, index card has a width that I measure of 7.68 centimeters to the hundredth place on centimeters, because I could read 76 millimeters and most of the next one, so I just said 8. And for length, my rectangular index card gave me a length of 12.71 centimeters. And if you look, let's answer the questions. It says measure them. There's no real place to record them, but you can record them if you show your work or not. But it says calculate the perimeter. So our perimeter for question number 2, our perimeter is equal to 2 times the length, plus the width, which is equal to 2 times 7, well, let's do length first, the way I wrote it, 12.71 centimeters plus 7.68 centimeters. And if you use your calculator, I had one here. I don't know what I did with it. Don't focus anywhere else. Well, it doesn't matter. I had my TI-84 here, but I've already done my calculations. I get a perimeter that's equal to 40.78 centimeters. I'm adding centimeters. For my area, it's equal to the length times the width, which would be equal to 12.71 centimeters times 7.68 centimeters. And if I do that, my area, and I plug that into my calculator, I get 97.6128 centimeters times centimeters, or centimeters squared. So I told you before, we call this calculator vomit. This is not, these numbers are not valid just because they're spilled out of a digital calculator. my actual answer, appropriately so, with 3 sig figs, when I multiply, can't have any more significant figures than my value with the least number of significant figures. So it would be 97.6 centimeters squared for my area and my perimeter. Now, we're done. You did your measurements, you did your calculations, and there are your answers. Now to the analyses and conclusions. How many significant figures are in your measurements of length? And for my width, it was 7.68. But for the length of the card, there were 4. And when we add, you might say, well, this only had 3 significant figures. But when we add, we can keep all the places to the right of the decimal point of the one with the fewest number of places to the right of the decimal point. These both had 2, so I can keep both of those. So, anyway, for my analysis and conclusion questions, number 1, it is 4 significant figures. I'll just write 4 sig figs for length. And for number 2, it asks for the width. And for width, we have 3 sig figs for our width. And that's because we didn't go over 10 centimeters, and it's just there. Now, the real question is, I'm going to do number 3, and then I need to move to a fresh sheet with number 4, because there are some real calculations there. Number 3 says, how many significant figures in your answer? And I can keep both of these when I add. So, when you report things in a lab report or on a test, I tell you plus or minus 1. Significant figure will still be counted correctly. Except for the concurrent credit college chemistry class, you need the correct number of significant figures. But the question is, how many significant figures in your calculated value for the area? So I had 3 sig figs. 3 sig figs for the area. And I'm going to have to write small. I have 4 sig figs. Significant figures for my value for the perimeter. Okay? Now, let's talk about how accurately we measured that card. We're limited by the tools we use. I'm limited by my vision, my glasses, and my light or lack thereof in my kitchen when I made these measurements. Okay? So it's possible I could have chosen a more accurate ruler or a more accurate some other measuring device. Maybe there's some laser rangefinder or something I could have used. Some sort of scanner. But now it says assume the correct length and width of the card are 12.7. So these are the accepted values. And they are length is equal to 12.70 centimeters. And the width, that's an L by the way, not an E. Width is equal to 7.62 centimeters. Now, it says calculate the percent error for each of your 2 measurements. Well, then I'm going to have to do the area and the perimeter. So the perimeter is equal to 2 times the length times the width. And if you add all that up, your perimeter will be equal to 40.64 centimeters. 12.70 plus 7.62 times 2. And you will get this value for the accepted perimeter. And the area, of course, would be the length times the width, which is equal to 12.70 times 7.62, and this 1 centimeters and this 1 centimeters. So my answer would be equal to 96.774 centimeters squared. That's what my calculator says, but my accepted value can only have 3 sig figs, so 96.8. Use your calculator, do the math, and see for yourself. So these are accepted values, but they don't give us the answer to the question, which is calculate the percent error for each of your 2 measurements. I would love for you, and I'll give you extra credit if you use your own measurements, but you can use mine that I've already ripped down and put away. But I will tell you what they were, the calculated values. So the percent error is equal to the difference between the accepted and the observed or the measured. Actually, the absolute value of that divided by the accepted value times 100%. So the percent error for the area is going to be equal to 96.8 minus, and I got 97.6 centimeters squared, but we don't need any because our value is going to be unitless. It always is, and I'll show you how that works out this time. Divided by 96.8 centimeters squared and times 100%. And if you do the math, this is 0.8 centimeters squared divided by 96.8 centimeters squared. Centimeters squared cancel. There go my units. Times 100%. And if you do the math, that's equal to, for area, 0.83% error. So my old eyes, my cheap scientific ruler, and my frayed index card gave me an error from the accepted industry standard value less than 1%. The percent error for the perimeter is similarly 40.64. Yeah, this was minus 0.8, but it's an absolute value. 40.64 minus 40.78. Again, I'm going to get a negative value, but I'm going to take the absolute value because I just want to know how far off I am, plus or minus. I could be above, I could be 0.83% above or 0.83% below. I just want to know how far off I am, the magnitude of that error, divided by the accepted, again, which is 40.64. Centimeters minus centimeters gives me centimeters for units. Down here, this is a centimeter value for perimeter, a length value. Centimeters cancel, so I'm not going to worry about my units. In a percent error calculation, they always cancel out, so I never bother about putting them down. Times 100%, so the percent error for my perimeter would be equal to the absolute value of minus 0.14 divided by 40.64 times 100%, and that gives me a calculated error of 0.34% error, about 1/3% error in my calculation for the perimeter. And that concludes our lab. I will see you in the next video. Until then, stay safe.
Isn't that supposed to be L plus W times 2?
Stop. Just stop.